So which text you want to appear in the message may depend on the recipient of that message. So if you have a group, a multilingual group, and then you may want to choose to use English as your lingua franca. So there's an English message. However, you may also want to use Hindi if it's a group of Hindi speakers, but keep it in the Latin script. So these are all, by the way, the same utterances that you might use. And you notice in Hindi there are loaner words, or words that are just have been adopted into Hindi, like party. Or you may choose to use Hindi with Devanagari, for example, if it's a text among your family members, and perhaps there are some who aren't used to reading in the Latin script. It's easier for them to read in Devanagari and Hindi, so that text would be in other language, in other circumstances. Here's a Romanized Hindi example from the wild. So this was an exercise in looking for memes in a language I don't speak that wouldn't get me into trouble. And so this one, so this is a good example of how rough phonetic transcription. So I can read it. I don't speak Hindi, but abye afwa kon faila raha haiki, which means something like, hey, who started the rumor that, something like that. And then the punchline is that Ronaldo missed the penalty shot as a tribute to Messi. Okay, so this is a joke about two people who are no longer in the World Cup. At the time that I added it to the slides, Messi was out for sure. But anyway. So I knew I wouldn't get in trouble for that one. I was looking for memes, and this one comes from the engineer bro. So you know that, yeah, anyway. Don't take memes from the engineer bro. Let's just put it that way, unless they're football related. Lack of standard orthography. So romanization, the key problem that I've set up to this point is that with romanization we lack a standard orthography for the linguistic input. And this is a problem for language modeling. So most language modeling methods rely on orthographic standards. Some kind of tokenization, perhaps segmentation into roots and affixes. When people talk about subword modeling in language modeling, they're typically taking a word and they're breaking it up sequentially into component pieces, not always, but generally speaking. And when you lack where the same word identity has multiple ways in which it may be realized, simply segmenting it into smaller pieces doesn't solve that particular noise problem. So I hope I've set it up to now that this is not just an academic exercise looking at the lack of standard orthography. There are important existing use cases. And it's not a new problem, and it's not an old problem, but it has been around for a long time. English itself had non-standard orthography not all that long ago, a few hundred years ago. And it does remain a relatively minor standardization problem for various sorts of media. And then, in addition, phenomena such as idialect have been and are common. So this is something that you'll see pop up now and again, and I'll show an example of idialect in a moment. But let's talk about historical English spelling. So this is from the Canterbury Tales. Me needed not do longer diligence to win her love and don her reverence. They loved me so well by God above that I need told no daint of her love. I don't know what it means, but it sounds nice. And if you dive into the Canterbury Tales a little bit, this is from the Cambridge manuscript. There's many manuscripts, so this was many of these manuscripts were created by hand, and the particular scribe would have their own way of writing the tales. And this is kind of a busy slide, but I just wanted to highlight these are from 3 different manuscripts for the same stanza and or fractional stanza. And here we have things like each blissful and 2 senses of fair. that are realized with different spellings, and I put the spellings over on the right. So here we get a fair bit of spelling differences between the manuscripts. You do get some word ordering differences as well. And so I guess the point from this is that in addition to not converging on modern spelling, it isn't just a transition from previous methods of spelling to modern spelling. It was that there was no agreed upon standard for how you would represent words with the Latin alphabet at that time. It makes sense because the same sorts of issues arise with this is a Romanization issue. The Latin alphabet was adopted for a language where it didn't fit the sounds all that well, and that's why we end up with our messed up spelling in English. One of the reasons. Whereas in a language like Spanish, where the Latin alphabet actually did represent the sounds pretty well, there are no spelling bees in Spanish because it's very easy to spell it. You spell it the way that you say it.
So in English, are you using the word orthography as kind of synonymous with spelling, or
yes.
Is there more to it?
I mean, standard orthography means that there is a standard way of spelling with that script. Please do ask questions. Barge in.
Is there a corpus of examples for this?
Of Canterbury Tales?
No, sorry. Of old pronunciation, old spellings paired with their modern standard orthography.
Probably.
You don't happen to have one, right?
I don't have one. No. But no, I went diving for this example, and but as far as resources go, it is something that people are attending to. I first became aware of this. So Richard Sproat invited a speaker at OHSU who was working. It was like a philologist from Scandinavia working on. Had a corpus of Canterbury Tales and was trying to do some kind of normalization between the different versions and to do interesting things like figuring out who the scribe was when it was unattested from a particular manuscript. And you could do that based on, say, authorship identification type techniques, in which case you'd need it in machine readable form. But no, I don't personally have it. So let's talk about iDialect very briefly. So iDialect is using orthography to try to represent how someone speaks. So this comes from Dickens. So the little dialogue says, "Stay, Joe, what now?" And Joe says, "It's time for me to go to that there burying ground, sir." Blah, blah, blah. "What burying ground?" "Where they laid him, as was very good to me indeed he was. It's time for me to go down, blah, 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 to the burying ground," and yar, 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 and it induces me to speak it with some kind of southern accent, despite the fact that it's Dickens. So this is something that you do see pop up in literature. Obviously, the obvious American examples are Mark Twain. Those are harder to get for public sharing just because they do contain a fair bit of sort of edgy material, I might say. Further, they tend to be, so you can ask what is the author signifying here with the use of this iDialect for this particular character? Perhaps the way in which the words were pronounced, so a non-standard pronunciation, but in addition he's signifying that this individual is illiterate. So these are, by using burying and burying as two variants of the same word, he's basically saying this individual would know how to spell this word if they were writing out what they were saying. There are corpora of slave narratives that were transcribed on the spot by individuals, and they did choose to use iDialect, presumably with the best of intentions, but it's yeah. So and same sort of goes for Twain's representation of certain characters. They always tend to be shown in iDialect. So this is another case where you would get non-standard spellings, and in fact a fair bit of spelling variation. And this also does persist into the current day. For example, in social media, you may see people revert to iDialect when representing certain dialogues. with all the trimmings of what it's intended to convey beyond the specifics of the dialogue. Right, so lack of standard orthography, so just reiterating this slide. And then I add the additional bullet. This also arises in cases where they're primarily spoken dialects. So for example, in Swiss German, for example, or in Arabic dialects, these are cases where there is no standard orthography on social media, and also in the case of romanization, which is what I'm dealing with in this talk. What to do with noisy romanized text? Oops. So the first thing that we tend to do, and this is the case in the sort of cottage industry of social media normalization. So normalization as a topic in our field has been around for a long time. In fact, there was a sort of very important early summer workshop here on this very site in 1998. 98. With such people as Richard Sprode and Mari Ostendorf, and Shankar Kumar was a student, and Alan Black, wow, now the Pantheon. And the other one is, who's the guy at IBM, Stan Chen? Yeah. Stan Chen, Chen Goodman. Oh, that's right, people don't do Ngram modeling. Right, so there's this paper called Chen Goodman. It's, yeah, it's a good paper. One of the best tech reports in our field. So, history. So the first thing, so the newish cottage industry in text, so text norm was sort of reborn maybe 10 years ago with the advent of social media. And so the first impulse of people in NLP is, give me noisy input, what am I going to do? I'm going to normalize it. I just want to make it standard so that I can do something downstream, like extract your information and all the other stuff. And as I showed with that demo, or that little example, it's useful in a keyboard interface, so you can do some sort of a transliteration. It's also useful in other cases for normalizing spelling variability and so on and so forth. Another thing, though, is to simply model it. So we can do language modeling, to use language modeling for this. Why would you want to do language modeling on this kind of normalized text? Well, many people choose to communicate via romanized text, even in their native languages. They don't necessarily want it to be transliterated into their native script. And so, as such, we need the language model in order to predict what they're likely to be typing as we decode their input on a virtual keyboard. It's kind of understudied, language modeling without standard orthography. So, and right now we have modeling methods that really can learn these dependencies without relying upon sort of a strict categorical segmentation and only looking at sort of pairwise dependencies between them. So looking at methods that would generalize. So towards the end of the talk, I will talk a bit about modeling of romanization directly. But let's talk a little bit more about another example of romanization in Hindi that will illustrate some of the problems that we find. So this is from a blog on India Today, and it's a blog post about corruption. And so there's a link in the slides, so I'll share the slides later. People can take a look if they want. And if you look at the comments into this particular blog entry, which was in Devanagari script, one comment begins, Brashtachar Admi Se Chalu Hota Hai. So those Hindi speakers in the audience don't laugh too hard at my pronunciation, which likely corresponds to the Devanagari shown there, and roughly translates to corruption starts with a common man. So this is how this reply to this one of the comments in the comment section, but it is left in the Latin script. That term, Brashtachar, is variously romanized in these comment sections. So if you take this comment section, which ran on fairly long, it was a fairly long set of comments. It occurs 16 times, so it's very topical. It was romanized thusly, sorry, it occurred many times. It was romanized thusly 16 times, another way 7 times, and then once each in a number of ways, some of which may correspond to simple typos and misspellings, but not all of them. And if you go to Google Translate, it will show a transliteration for the Hindi terms, and it romanizes it in yet another way. So there's a lot of different ways in which you could choose to romanize this particular term.
None of these are like subtle variations on the word corruption. They're not.
None of the, they are all the same word.
So
this is the word. And which you can sort of see. So what have they done? They've sometimes they include the H for some sort of an aspiration. Sometimes they don't. Doubling of the vowels. I guess Google Translate does that, and the others not so much. Put a vowel between the R and the rest, but others not. So there is a vocalic R in Hindi, so sometimes you don't need to have another vowel there. So sometimes they include it, sometimes they don't. One of the complicating matters, I think in all cases here, we're typically seeing a rough phonetic transcription. That's a transcription. I would call that transcription. They're basically transcribers using the Latin alphabet of the utterance. Sometimes there is, strictly speaking, transliteration. And so the difference is that you're going from one writing system to the other. So, and when I say we're seeing transliteration in addition to transcription, transcription is driven by the pronunciation. Transliteration is driven by correspondences in the writing system. So there you might be going directly from a particular symbol to another particular symbol, and you're influenced by the way it's written and not by the way it's spoken. So what evidence do we have? I will show some, right. So I'm going to show some evidence about transcription versus transliteration. So it is very common when there is no standard that it's largely transcription versus transliteration. In Arabic, there is a standardized format called Arabisi, which does include elements of transliteration, where, for example, numerals are used to correspond to specific symbols in Arabic. So up to now, I've been talking about Brahmic scripts, which are used, for example, for Hindi and Tamil. But it's also the case in non-Brahmic scripts used in India. For example, Urdu and Punjabi and some of the others where they are using Arabic, Perso-Arabic scripts. They also are doing a rough phonetic transcription. So modeling transliteration, what we are calling transliteration, or moving from the Latin representation to their native script, has some similarity to modeling pronunciation. So that is the way of setting up sort of how we choose to model this on our devices for the keyboard, which I'll get into technical details in a little bit. It's interesting, many of the Indian languages have multiple native scripts. So when we talk about the native script of the language, these are conventionalized, and it depends on your group. So most of the regions bordering Pakistan and also Hindi and Urdu are roughly the same language, modulo the writing system that's used. So supporting all of native conventional scripts is kind of a key desideratum if you're building a system to do this. So for example, if we're building a keyboard that's going to take Latin input and transliterate to your language, you probably want to support both scripts for Punjabi. Otherwise, you're sort of making what could be interpreted as something of a political statement, which you probably don't want to make. We didn't want to. And what's interesting is that the romanizations are actually similar across scripts for the same language. So this is evidence that it's more of a transcription than a transliteration. So let's look at some data that we collected. So this is Hindi romanizations of two words, both of which share the first syllable, san. So Sanskrit and the word corresponding to complete, which I'm guessing is pronounced something like samparan. And so here we have the native script representation, and here are the romanized forms that were in our manually labeled. So we sent these out to, I guess, I don't want to say linguists. I don't think in order to elicit romanizations, you basically need native speakers who have the ability to follow this sort of task. So we actually did it with something akin to a mechanical Turk task. So this sort of data is actually relatively easy to elicit. You don't require, this is not a phonetic transcription. So in contrast to building pronunciation models, this sort of data is sort of there for the asking, if you get the right, with native speakers. And so here, this is a case where we do see the vocalic R is showing up. Some people put the vowel, some people don't. And then what we also get is we get differing vowel identities. So the Latin vowels don't map very particularly well onto the Hindi vowels, so you'll get some variation there. You will get some doubling and stuff like that. The other thing to note on this example is that these are both starting with the first syllable san, so that is with a nasalized vowel, but in the romanization they show up differently. So we are getting co-articulation effects from this. So we get Sanskrit and Sampuran based on the following consonant. And so this is evidence that this is a phonetic transcription as opposed to a transliteration, which I think is cool. Then we can look at Urdu, and we get the same words, Sanskrit and complete, for Urdu. And we do get overlap. So you can see we actually get perfect overlap on 2 of the Sampuran romanizations, and Sanskrit, we get some standard variation there. The other point to point out here is Urdu is based on a Perso-Arabic script, so the native script at the far end is a consonantal script, so they're not representing the vowels in the script. But in the romanization, they are representing the vowels. So this is another piece of evidence that they are using rough phonetic transcription instead of direct transliteration from the writing system. In other words, they're not particularly influenced by the writing system. And they're not using Arabizi, which is what is widely used in the Arabic-speaking world. So when I had a conversation with Nizar at NACL about when they look at their romanized text, is it more transcription versus transliteration? His intuition was that it was about 50-50 in the language that he was looking at. So it's both. So I think with Arabic, you are getting a bit more, and I'm not saying that Urdu doesn't come through. So I did search for tokens without vowels in the romanized data, and it was a very small percentage. It did show up, but a fairly small percentage. Here's an example from Punjabi. So Punjabi has 2 scripts, an Indic script and a Perso-Arabic script, and again, you see overlap between the romanizations between the 2 systems. So key points to take away from these examples. Languages are written in multiple scripts. You need to be able to cover those different scripts in whatever you're trying to do if you're producing it in the native script. In this case, we're talking about writing systems that are grossly different in their organizing principles. So the Indic ones are alpha syllabary, so it's focused around an orthographic syllable, and I'll talk about the mechanics of how that writing system works a bit. Whereas the Perso-Arabic is consonantal. We see core articulation effects, so not generally transliterating in this case. So the one exception to the fact, to the cases where the script influences the romanization are English loanwords, because in many cases they are produced as they're spelled with the correct spelling in English. And so, so in that case, if you're trying to build a pronunciation model, well, we know how English is spelled. It doesn't necessarily correspond to the pronunciation. So that is an exception to this rule, is that English loanwords often are put exactly as they're written in English. So let's go back to our text entry example and keep that in mind. So we get things like party as a loaner word. That may be, that is a word in Hindi. And when we transliterate to Devanagari, we will represent it in Devanagari. So our transliteration system needs to be able to cover all of these sorts of phenomena. Final points, vowels included, I already said that. Pretty low inter-annotator agreement, so we saw that in the examples I showed. There are many different kinds of ways to romanize, so it's a pretty noisy input task. All right, so for the rest of the talk, and I'm going to kind of speed through this, since I guess I've got about 15 more minutes or so. I'm going to give some details of the current Gboard transliteration keyboard, some specifics of the Brahmic script and the low resource modeling methods. We launched 22 languages in 2017, some with multiple native scripts, and we've launched more in the meantime and more forthcoming. And then I'm going to briefly talk about Romanized keyboards without transliteration and some thoughts on modeling of Romanized text. So let's talk in detail about these scripts. They're descended from the Brahmi script, hence the term Brahmic. It includes Devanagari for Hindi, Bengali, Tamil, etc., and excludes things, the Perso-Arabic scripts. They look different, but they share similarities. So this is the word Sanskrit in 4 of the Brahmic scripts. So they do look different, but they have similar organizing principles. Why do we focus on these languages? Well, Romanization is extremely common in these languages and is under-supported on mobile devices. And so these are the number of native speakers from a 2001 census, so it's more than this now. Mother tongue, which I think is slightly different from native speaker. So native speakers is probably higher in many of these language bins since people are multilingual. So this is a lot of people to be underserved by language processing applications that we as a community are responsible to provide. So how do they work? They're organized around an orthographic syllable. They use the term syllable in English. Aksara is the term. We immediately think of the syllable in speech, but it's really an orthographic syllable, so it doesn't necessarily correspond to syllables in speech. It's basically consonants with a vowel. The consonants come with a default vowel, so you can indicate that default vowel without an additional symbol over and above the syllabic symbol. And then you would use a diacritic to indicate a different vowel, or perhaps to indicate that there is no vowel with it. So this san in Sanskrit, I already talked about it, that little dot is the sa syllable with the default vowel, and the diacritic indicates that it's nasalized. And then when you have consonant sequences like skr, it's formed into a complex ligature. So this particular ligature for the second aksara in Sanskrit is actually these 4 Unicode code points. And one indicates that you have sa, the same syllable, but with no vowel. Okay, so you leave off the a, so that's that diacritic, and then the k with a vocalic r syllable instead of its default. So that particular ligature is that combination. So when we process it, we have a string of Unicode code points, and then there's some rendering apparatus that has to turn it into the complex ligature.
So the third character there is a combining character, even though it doesn't look like one?
Which one? Here?
Yeah.
No, that's...
you said it's all a single ligature. So
this is a k.
Yeah.
So this is sa, no vowel.
Right, but I thought you were saying that all 4 are combined.
Yes, so the rendering, you're not giving extra. I think there are certain...
That's just rendering, it's not considered a combining character.
It's rendering, yeah, you don't need a combining character. There are certain, zero width space that pops up sometimes, and other noise. But for all intents and purposes, we can treat this as a Unicode code point sequence. Right, so making the case that this is similar to pronunciation modeling. So if we had a lexicon in speech, the word like though would have its pronunciation however you choose to represent it, the and o. If we had a standard keyboard, we'd also typically have a lexicon, and the way you produce it is trivial. It's simply the spelling out of the word as it's spelled in the script. And then finally, if we reintroduce transliteration, our target word is in the target script, but we have its pronunciation as the romanization. So we can see that this is very much like grapheme-to-phoneme conversion, and in fact, we do use very similar methods for this transduction.
So Brian, in that early example you had of the word Bhraštachar, which had 17 of one, 7 of the other or something,
Yeah.
would you put those in as multiple pronunciations of the same word?
Correct. Yeah, so we have each of those as a training example, so we have a pair. And we do want to, so this is a recognition task. So we're typing in Latin and we're producing the target script. So this is akin to ASR. We want many, however they may produce it. Like in speech, the spatial model. So the spatial model is like the acoustic model. So that's when you're combining your touch points and you're figuring out where they actually touched. That serves the role of the acoustic model. That can carry some of the noise, maybe. Okay, but some of the noise needs to be carried around in the lexicon, which is the transliteration model that we're building. And unlike a production case where we would presumably want to have a canonical romanization, if we were producing romanizations from the native script, we'd want to have a canonical romanization, similarly to having a canonical pronunciation in the case of TTS.
And in terms of suggestions, do you suggest like multiple?
Suggest, in that case, the suggestions would show up in the native script. So we would have, but it is a fair point, if we have a non-transliterating romanized keyboard in the language, which there is a version of, and there, it's a good question. It's a good question. I think there we would have a canonical romanization. Yeah.
How do you handle named entities, which there may be like many named ones that happen?
Well, we have a lexicon, so some, but as far as new named entities, perhaps there is an apparatus in the keyboard. There certainly is an apparatus for personalization. And so, but I don't think there's any specific named entity processing happening inside the core model building and or decoding process. But if we did, we would use SAFT.
In fact, Divanjan might be pointing to something which is a difficult problem in the other direction. So we were mostly talking about how the word in native script form could be romanized in multiple ways, and there's some unpredictability how it's done.
Yeah.
With proper names, it's how it is rendered in the native script that's often a problem.
Right.
So if you have Messi and Ronaldo, like you had in the examples, I'm not sure everybody would write Messi exactly the same way in Devanagari. So
Right.
some would write it with an A, some would write it with an S, or some would be Messi, others would
Yeah.
be Messi.
I mean, loaner words can be the same. We do see romanizations, and then potentially, I guess in Devanagari, if it were a true, maybe a foreign word example that's not part of the standard vocabulary, it may be realized in Devanagari in slightly different ways.
Yeah.
So, yeah, not so much special done there, although it's something that we probably should take a good look at. All right, so now I'm going to talk a little bit about how we implement these things on the phone. So like speech and OCR, I hope I've made the case up to now, Gboard requires inference over a search space. So we have a decoder operating. We're combining some kind of an input model, which is like the acoustic model in speech. It's a spatial model in Gboard, and with an output language model via a pronunciation model or a transliteration model. Weighted finite state transducers have been used in speech, continue to be used, and they permit offline combination and optimization, and so we're doing the same thing here, particularly because we really do have limited real estate on the phones, and it's very common in India, for example, that there would be pretty low-end smartphones that have much less space than, say, what we tend to carry around. So it has to operate, I think we have in aggregate, I say later, maybe 5 megabytes in aggregate for all of the models that we have. and on the order of 10 milliseconds for decoding. So we're trying to do as much offline optimization as we can. Transliteration is represented as another weighted transduction in this overall decoding process. And we use, for this, pair language models, also known as joint multigrams. Bassani and Nye coined joint multigrams. We tend to say pair language models. And these form fairly compact weighted finite state transducers. And we do several optimizations for on-device representation. One thing we could have done was simply use a lexicon. So we just list a lexicon, and that's what we have. That's the pronunciation of that particular word. However, there's much less consensus for romanization than pronunciation. And so when we tried this, if we use, for example, the 10 best word romanizations in a fixed lexicon, we saw a pretty big word error rate increase versus using a transducer that has many more possible romanizations. We want to allow people to be noisy. So how do we derive this? We have a lexicon entry that's a target word and its romanization. EM, standard EM, can yield a pairwise alignment, a symbol wise alignment with epsilons on the input and or output. And then from this, so when I said pair language model, what I meant was these pairs of symbols with input and output Unicode code points. And so we can build a simple model that predicts subsequent pairs based on previous pairs in the history. A simple compact automaton that has such a model, we can convert it to a transducer and use that as our, we have input Unicode code points and output Unicode code points, and it all joins up inside the decoder. There are some issues around eliminating epsilon cycles and other optimizations that I'm sort of going to gloss over here. And I am going to, maybe I'll make a few points about why pair language models. Very general method, so it's script. We don't build in any special knowledge of syllables, so applicable broadly. I made the case earlier that we do need to support various kinds of scripts. We can model pronunciation effects, so since we're not dealing with syllable by syllable, we can get cross-syllabic co-articulation effects. In addition, we now have a transducer that can go in both directions. So we can take an input word in the target script and auto-romanize it into a lattice of possible romanizations. So if we have a training set of, say, 100,000 words, types, then we can augment our vocabulary and include those possible romanizations into our model as well. So it allows for a certain amount of sort of self-training on a larger vocabulary. It does require, so it is a joint model over input-output sequences. So since we're modeling over these pairs, we really are modeling both the input and the output jointly. And so inside of a decoder where we want to have the probability of the romanization given the target symbol. So we require a conditional normalization factor to be available during decoding. So I'm going to skip over this and just point to what the final transliteration automaton would look like. So this is a bigram automaton. Each state, if you have multiple, so actually I guess I don't have to point with my finger. I can use, so for example, this state number 5 here, I'm just numbering for convenience. All of the incoming pair symbols are the same, so this is the context. And outgoing arcs would have their probability conditioned on this incoming pair symbol. So what's the probability that RI maps to this symbol in the Devanagari Unicode block, given that it was preceded by K mapping to this particular symbol in the code block? So that's the structure, that's the automaton structure. From that, we now need to map to a transducer, but you'll note that we used EM in a specialized way that I glossed over, which is instead of single Unicode code point to single Unicode code point, we did a second pass of EM that allowed us to combine some of these symbols. And so we get multiple symbol correspondences. And so mapping to the transducer, And this is just a summary slide. There is a paper on this, and so I would, if you're interested in the nitty-gritties, you can read it in the paper. But basically, we have a method for turning it into a transducer that maximizes structure sharing. So note that all of these start with the letter S and then have subsequent, potentially subsequent letters. So we share all of these arcs together. So it's a form of determinization. Most importantly, rather than the structure sharing, so we do get a space savings because of this, but rather than that, we also get what's called weight pushing, meaning that we get probabilistic evidence as early as we can. By doing that, we get the aggregate probabilistic evidence of all the continuations that start with an S on the input side. And that's important because we have a decoding process that's using beam search. So we want to make those beam search decisions, those pruning decisions, with as informed as we possibly can be. So it's really the weight pushing. This is also the case with speech decoding as well. This is why forming a big CLG and using all of those fancy algorithms to do it with a sort of a pseudo-determinization, you get structure sharing, but you also get the weight pushing that informs use within a beam search. The second optimization, and I really am running out of time here, so I'm okay?
Fine.
Okay. Is to how we encode the actual lexicon and the language model. So because we convert from Latin form to the target script, at the time we reach the target script, it's really just spelling out the letters. So this is the lexicon L composed with the grammar G, LG. Because of that, we don't really need a transducer. When it's in speech, we have phones mapping to words. You can't just read off the phones and have it spell out the word, but here you can read off the letters and have it spell out the letters. So we can convert it to an automaton, back from a transducer to an automaton, and just have an end of words symbol that the decoder knows about. And so that leads to some pretty big space savings that I'll show a number for. And then this is the sort of algorithmic details of deriving this normalization factor. Because the transliteration model is a joint model, we need it to be conditional. For each word in the lexicon, we need to calculate a normalization factor. And this can actually be done with general finite state methods, composing with a lexicon, projecting to the output, which gives us the words, removing epsilon and determinizing over the log semi-ring sums all of this probabilistic evidence into a single value for each word.
Because words are finite.
Yes, so because we have a lexicon, it makes it easy. Yeah. And details are in the paper. So just to give you a sense of how important this pushing is, so this graph has latency, so these are milliseconds on this side, and this is word error rate. It's sort of, so here we're boiling down, did we guess the correct word based on the input touch points? And you can see that with no weight pushing, and this is with the transliteration model weight pushed appropriately, but the LG not, and this is with LG appropriately pushed and all that, we get down in this bottom left-hand corner, low word error rate and low latency, which is where we want our operating point to be. That's basically the point I wanted to make here. These issues matter. As far as size goes, this is turning it into an automaton, and then we can use all kinds of fairly general automaton representation methods. And the louds is a method for encoding language models, and you can see we get about an order of magnitude savings in terms of how big these automata are for storing on device. And in fact, we've made them even smaller in the meantime. And we launched this in 22 languages, blah, 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 more in preparation. So in my last 2 or 3 minutes, let me just talk a little bit about modeling Romanized text. So open vocabulary modeling is really needed in this case if we're dealing with Romanized text. So I gave this example of having many possible ways of spelling this particular word. Simple segmentation-based subword models don't solve this problem. Subword parts are also unnormalized. So if we break it down by the orthographic syllable for this particular word, we can see the variation that we get at each of the syllables. And so we simply, by performing this sort of subword segmentation, we sort of kick the can down the road. We still have this many-to-one mapping that we really want to, if we want to know the subword identity, we still would need to perform some kind of normalization process. So transliteration is a way to model Romanized text. So it's performing a normalization. We're mapping from these noisy Romanizations to a particular correct way of spelling. And so we do have joint probability over Romanized and associated target. One other thing that we've been looking at to avoid this sort of marginalization is doing some kind of multitask training. So if we could perform some kind of secondary task that performs the normalization while we're training language models on Romanized text, for example, some kind of sequence-to-sequence loss for mapping between the Romanized and the native script, as we're also training a language model on the Romanized script. Then at test time, you have a language model on the Romanized text that has been informed about equivalence classes for the particular sequences that they're modeling, and hence may be in a better position to capture the kinds of longer distance dependencies that we want. So that's a big current effort. LSTM, language modeling of Romanized text. I'm working with Keith Hall and Dan Garrett on this. The scenario, so we don't have a parallel corpus where you have full strings in both Romanized and in the target script. So we're interested in a scenario where we have a Romanized text corpus, a transliteration lexicon, so the kind of lexicon that we've been using up to now, and also perhaps incorporating native script, and then looking at multitask learning with an LM and transliteration losses for open vocabulary character-based LSTMs. And we're also looking at languages with multiple native scripts where we perhaps could leverage the fact that they have multiple native scripts to get more information from these other things. So look for we'll probably, at this time of the year, probably put a paper in archive at some point. I think I said this summer, huh? That was a month ago. Sometime in the fall. A few interesting questions to close on. Might long distance dependencies matter? We tend to look at things like pronunciation modeling as a local phenomenon. It's sort of co-articulation. But I think there's some reasons to think so. So there are individual tendencies for romanization, and furthermore, since it is pronunciation may be driven by dialectal variation and things of that sort. But does this person use the H for aspiration? Do they double the vowels when it's required? If the answer is no, then perhaps that sort of information could be used. And then the second one is, can auto-romanization from simple models improve language models trained in a sort of richer modeling framework? That's something we're looking at. So thanks. Here's a list of my collaborators. This sort of thing doesn't operate in a vacuum, so there were many, many people that touched this project through the couple of years that we've been working on. And so I'll stop there. For many questions, however many you like. So, who wants to start? Anyone from the students?
So I'm trying to understand the distinction you're trying to make between transcription versus transliteration.
Yeah.
I understand the definitions, but what I'm trying to understand is how does that affect how you design your system? Right? You say that transcription is more common in the Brahmic scripts that you're romanizing. How does that affect? Like if you do Arabic where it's 50-50, how does that change things?
Yes, so how it changed it in practice versus how it should ideally change it. How it changed it in practice, not so much. So we sort of have a bunch of exemplars and we lump, in the case of the Brahmic languages that we've been modeling, or and the non-Brahmic languages, the Indian languages that we've been modeling, we sort of have a lexicon that does include English words, which are the ones that really are driven more by the orthography than the pronunciation. we throw them, we just include them all. And that actually does seem to be a strength. So that when we use the transliteration model, so with Dan Garrett, who some of you may know, so he's been working on using general use of transliteration at other points, not for Gboard. And we use the same engine to perform the transliteration or auto-romanization in either direction. And in his case, he has been looking at problems quite a bit further along in the search stack, where we actually have romanized text that people are searching on, and we want to be able to make use of that. And furthermore, we end up with a lot of English in Devanagari, for example. And so if you want to do something like match with a named entity for retrieval of some structured information, one of those sidebar things, then it's helpful to be able to move back and forth. And so having English words in our training data actually was quite useful because it actually does a decent job on the English words. But as far as distinguishing between transliteration and transcription in the modeling method is very general. It's sort of script agnostic. It's like, give me correspondences. I'll use EM to figure out sort of rough pairwise alignment, and then I'll build a model over those things. So it covers both, however it would show up. Whether that's optimal or not, I'm pretty sure it's not. So one thing that we might think about doing in other transliteration systems inside of Google that have been used in the past did this. They would use a separate path for English loaner words that might be spelled with the standard English spelling. So what you could do is you could have sort of the union of a couple of transducers, each of which models, one models transcription, one models transliteration, and then they duke it out as far as which one gives you the most probable path. And that might be a way to do a better job of modeling it. And that would have to be at the word level, because one would assume that perhaps one token would be a transliteration and maybe the next one would be a transcription. But I really haven't exhaustively looked at this. Early attempts, sort of buried in the history of this project, showed no gain for doing this sort of thing. But I would imagine that there would be some modeling gain to attending to that a bit more. At this point, we've tried to be sort of as script agnostic and as sort of process agnostic as possible.
On your last slide, you talked about, like, you compared local dependencies like articulation and long distance. What do you mean by long distance dependencies in the context of like individual tendencies?
Yeah, so so say I've got a string, say I've got a tweet in Romanized Hindi, and I'm I'm modeling what's a likely. So somebody's writing this as we go, and they're on the last token. They've typed 10 words. Can the model be informed by the fact that in the previous words I didn't use the H for this particular word when that is a legitimate variant of Roman? So what is it, Brashtachar, which is, I don't know, knowing corruption, I guess, in this day and age it's a good vocabulary item. But Brashtachar has that aspiration indicator. I'm assuming that's what that's indicating. H. In some of the instances, but not in the others. If a particular individual omits it, then perhaps that's information that could be leveraged in the same string downstream in terms of modeling what our expectations are about the next character that's likely to be typed. Does that make sense?
Yeah. Why would it be like inside the string thing? Would you be like redoing that long distance dependency, relearning it every time, or is that something else?
No, I think if you did have the right kind of training data where you had romanized data, then the model could learn that you do get these consistencies within a particular string. If I see an aspiration at some point in the string, then I'm likely to see it elsewhere where required. So it would simply be something that would perhaps be, it's something implicit that the model might end up attending to and leveraging when predicting subsequent characters quite far downstream. I mean, the same may be the case in pronunciation modeling, but it's been hard to leverage. I mean, long distance dependencies, generally speaking, are difficult to leverage. but I suspect that they exist. Another one would be dialectal identification. So this person, there's a certain class of individuals that pronounce it this way, and hence they romanize it this way to the extent that it's a rough phonetic transcription. And so if you can identify that early on, you might be able to leverage it later on.
There are also dialectal conventions for romanization. So there's a T sound. There are actually a couple of different T sounds in many of the South Indian languages which don't exist in English. And so some people use T, the single letter for something, and other regions they use a TH. And this happens even in names. So you might have a name like Mamata, which is one of my cousins, and she spells it with a THA in the end. But the same name in the north of the country would be spelled TA with no H. And this is consistent. So somebody who writes that way will always do that. And so if you picked it up once, you could pick it up again, and the two characters would be different for how you write them.
I think that's what I was thinking of, like the difference between doing it in an individual instance of someone writing something and like having you can sort of safely assume that someone has a private phone, and that you wouldn't have to relearn each time you use your keyboard.
Yeah. So there is a personalization mechanism so on device, a little personal model that gets, with appropriate opt-in, of course. And then that is leveraged. In fact, there is a specific Romanized Hindi keyboard that exists in Gboard. It's not widely used yet. I mean, it's fairly new. What many people use, what many Hindi speakers use, is just US English keyboard, and then they personalize it to that weird form of US English that they use, which is Hindi. And so that's how people, they personalize Hindi on their device, which is not the most efficient use of that personalization mechanism, but it is sort of the escape valve. So for things like common proper names for Sanjeev's cousin, it would end up in his lexicon, and then that would influence the expectation at any given point for that particular romanization.
And the one problem is that the personalization is not being shared among all the people who do this. So there's no global Hindi language model where one speaker can influence another.
Yeah, so this gets into interesting and potentially fruitful learning approaches like federated learning, which you may have heard of, where...
it's also graded, like my cousin's main example, everybody south of a certain mountain range in India spells it one way,
right.
everybody north of it.
Yeah.
So it's a regional thing.
It's a litmus test, right? You can tell where somebody's from. So, so there would potentially be ways where you sort of can share information without violating individual privacy, but for current versions, for the most part, that will live on the device, correct. So each person would be personalizing to him, which makes it obvious that we should have a better starting point for that use. Yeah.
But is the personalization shared across lexical items? Or is it only shared, it would be like it learns the name and then it doesn't use that?
It would be like creating a little unigram model, or maybe a small n-gram model. So yes, no, it would not generalize. Yeah. And we don't personalize the transliteration model. So if they were using the transliteration keyboard, that's a to-do, is figuring out how to personalize the way in which they tend to transliterate and influence that model, because that would then, for people using the transliteration keyboard going from Latin to their target script, that is also, we would pick up some personal idiosyncrasies. Yeah.
On the topic of creating a global model for all speakers of the language, so there's been a lot of discussion lately about using differential privacy and things like that to try to address in terms of transmitting your data up and down.
Right.
Has Google tried to adopt anything like that, or have you thought through how to be privacy preserving while also gathering the tons of interesting data that users can provide?
Yes, so Gboard actually has sort of TensorFlow hooks on device and those federated learning algorithms do exist. Now the modeling part is the tricky part, and so as far as I know, they haven't replaced a lot of standard modeling methods, but many of the you can have guarantees, pretty strong guarantees on privacy and security and all the rest of it, and so that does exist. In fact, people on our team are also looking at ways of using that mechanism to train other kinds of models. With some of the, so there are neural models for word prediction, not word completion so much, because that requires integration with the decoder at a latency that's tricky. But word prediction, where at the word boundary you try to predict the next word, so there are neural models that will perform that. And so those models, I believe, for people that opt in on that, and I don't know what the numbers are, but those would be trained using a federated learning setup. So yes, there's a whole group up in Seattle that works on this sort of stuff that common acquaintances work with, and so on and so forth. Yeah.
I have a sort of not fully formed question.
Sure.
So since you talked about federated learning, now this assumes that the data that everybody has is good. But if there is noise, a purposeful noise, how, or random noise, how? Because you're not sharing everything.
Yeah, I mean, noise is part of the whole learning thing. I mean, noise is introduced, and the hope is that the aggregation handles the noise. So the scale of the aggregation is required for learning to occur. So that's the answer to that, is just large-scale aggregation will handle the noise element, some of which is purposefully introduced for the purpose of privacy, so on and so forth. So, and in addition to privacy, there is a lot of work on security, so adversarial settings, if that's what you're referring to. People are looking at adversarial settings, and there are methods there also. So, yeah. Not my world, but I'll use the algorithms once they exist. So.
I have a question, but let me check if there's one more. Okay, so my question had to do with the whole weight pushing business.
Yeah.
Of course, we use it all the time, and we've always thought of it as something that helps us make the search and especially the improving version and all that. But in this case, I was wondering how it impacts, like, the predictive things you do, and whether users click on a completion, the autocomplete, and whether they use a completion that you suggest. Do you have any data about if you do it, don't do it, or do it better, whether people will find better completions, or is there anything?
So the decoding of the touch points is independent of the predictions at the top. So it may use the same model, but the weight pushing is really used for string decoding over the sequence of touch points. In addition to that, there's a second algorithm that at certain key points will sort of walk the search graph in advance of where you are and figure out what likely continuations would be, or predictions if you're at a word boundary. And so that, this is walking the transducer, that particular algorithm isn't necessarily impacted so much by the weight pushing because it's not using a beam or anything like that. And secondly, there are complications with that because of the conditional normalization factor that we have to introduce that I was talking about because of the joint model. For the transliteration keyboard, that complicates the word prediction and complete. We dealt with it. It's just an additional factor that needs to be kept in mind. But generally speaking, it doesn't impact the word prediction and completion. And so, yeah. Yeah?
Go ahead, Jason.
I'll take it offline during lunch.
No, we have a few minutes. So
Okay.
Fine.
We did? Okay. All right. Well, so let's thank Brian again. And I have a couple of housekeeping announcements, but before I go to that, So Brian, since you went from Brown to AT&T to OHSU to Google,
Yes.
I'm guessing your next move is going to be to academia. So to help you keep us in mind, I'm going to put CLSP on your head. So you can think about us when that time comes.
All right.
So thank you again. So housekeeping announcements. One, 3 or 4 of you sent me emails saying you want to meet with Brian.